Yes, let's look at this question. It's another calculation. So we have a piston cylinder contains 0.90 Kelvin kilogram of liquid water and 0.10 kilogram of water vapor at 500 kilopascal. 500 kilopascal is the same thing as saying 5 bar. When 2000, please, this is not 200, it's 2000. When 2000 kilojoule of heat is added at constant pressure, what is the final temperature? What is the final temperature? And what phases are present? That is the question. So we'll make this little sketch. This is 0.1 vapor, and this is 0.9 liquid. Pressure is 500 kilopascal, and it's moving to this other system 2, which is 500 kilopascal still, but we are looking for the temperature there. So to do this calculation, what we simply do is that we use the first law of closed system at constant pressure, and we also use steam table. So, and that states that del U, change in internal energy is equal to Q plus W, which is the same thing as saying Q minus P del V. So Q is equal to change in PV, and del inter P is equal to change in U plus change in PV, which is equal to Q, which we already know. But in essence, H2 minus H1 is equal to 2000, which is the heat added. So now, knowing that that is the equation, we can use from steam table. From steam table, we can find H1 for mixture to be equal to M liquid, which is the mass of liquid present, enthalpy of liquid present, plus mass of vapor present, enthalpy of vapor present. If you go to your steam table and check at pressure of 5 bar, you're going to find out that the H for the liquid is 640.2, and that of the gas is 2749. And you're already given that we have liquid of 0.9 and we have gas of 0.1. So if you multiply out, you have H1 to be equal to 251.1 kilojoule. So if you put it back in this very equation that says H2 minus H1 is equal to 2000, we will now make H2 the subject of the formula, so that H2 equals to H1 plus 2000, which will give us 2851.1 kilojoule. So that is your H2. So if you now check, H2 is very high and it's going to be superheated. So if you go to the superheated side of the steam table, you're going to find out that at H equal to 2851 and 5 bar, you're going to get temperature to be equal to 198 degrees Celsius, which is approximately 200 degrees Celsius. And you know that Tsat for this situation is 151. That means that the temperature of 200 is highly above 151. So we are going to find out that we have only vapor. So that's why in the question that says what is the final temperature and what state? The final temperature is 200, or you can say is 198. And what phases are present? You can simply say that it's only vapor, because the heat involved here is 2861, which is very high, and the temperature here is 200, which is higher than the saturated temperature. So at this time you'll be having only liquid, only vapor, because 200 degrees Celsius is far higher than 151.9. So that is that. Please, if you like this, hit the subscribe button, like and share our videos. Thank you and God bless you. Yeah, I'm recording like this because I'm the only person in the recording. I don't have somebody holding stuff for me. So thank you. God bless you. So in essence, this calculation, you center mostly here where you have H2 equal to H1. H2 minus H1 equal to 2000. So use your steam table to find the various this thing, multiply out, you get it. Then anything you get, add it up to 2000 so that you get the final this thing. Then what you get there, get back to the steam table and use it and locate the temperature. Thank you and God bless you.